Unitree Go2 X Robot Dog Review. Embodied AI platform developers can actually afford. You're staring at simulation results that look perfect. Your reinforcement learning policy nails every test case in Isaac Gym. Your SLAM algorithm maps flawlessly in Gazebo. Your vision model detects objects with 98% accuracy. Then you try deploying to real hardware, and everything falls apart. The robot stumbles on carpet it should handle, loses localization under tree cover, or costs $75,000 before you even write a line of code. You're stuck in endless sim-to-real transfer hell, watching grants evaporate on platforms that either can't handle dynamic terrain or require enterprise budgets just to get started. Your research timeline stretches from months to years. Your startup prototype sits frozen because quadruped platforms are priced for Fortune 500 companies, not independent developers. And here's the thing. You're not asking for the impossible, just accessible hardware that can actually run the AI you've already built. Sound painfully familiar? Drop a comment if you've hit this wall. Every week without a physical platform means another week of theoretical work that may not survive contact with reality. Your competitors with bigger budgets are already field testing on Boston Dynamics Spot while you're still writing grant proposals. Students in your lab are learning robotics entirely in simulation, graduating without ever touching a real quadruped. The pressure builds when conference deadlines approach and reviewers demand real-world validation, not just simulation graphs. You've considered cheaper wheeled robots, but they can't climb stairs, navigate rubble, or demonstrate the dynamic locomotion your research actually requires. DIY quadruped builds sound tempting until you price out brushless motors, realize you need custom actuators, and face 6 months of mechanical debugging before you write a single line of autonomy code. The weight of compromise, dumbing down your research to fit available hardware, or waiting indefinitely for budgets that may never come, quietly drains the innovation and excitement that brought you to robotics in the first place. There has to be a platform that meets developers where they actually are. Then I discovered the Unitree Go2 X, and the gap between simulation and reality finally closed. Don't just pick any quadruped robot. Make sure it has full ROS2 integration and open SDK access so you never suffer the frustration of lockdown platforms that block the exact research you need to do again. The Go2X is a developer-first embodied AI platform built specifically for researchers, engineers, and serious hobbyists who need Boston Dynamics-level mobility without the $75,000 price tag. It runs on dual LiDAR and depth cameras for autonomous navigation, handles 40-degree slopes and stair climbing, reaches speeds over 3 meters per second, and ships with an NVIDIA Jetson compute module that runs your neural networks in real time. Setup to first autonomous navigation took 1 weekend, not 6 months. If you've been waiting for quadruped hardware that respects your intelligence and your budget, this is it. Imagine deploying your trained reinforcement learning policy to physical hardware the same week you finish training it. The Go2X handles dynamic trotting across grass, gravel, and uneven ground with stability that rivals industrial platforms, while the onboard Jetson Orin runs YOLO object detection, SLAM mapping, and custom neural network controllers simultaneously without latency. Robotics researchers at top universities consistently report successful sim-to-real transfer within days using Majoko and Isaac Gym workflows. One independent developer mentioned prototyping an autonomous security patrol robot complete with thermal camera and cellular connectivity in under 3 months, something previously impossible without enterprise budgets. Technology reviewers note the actuator torque and joint control bandwidth genuinely support advanced locomotion research, not just pre-programmed demos. Worried about durability during the inevitable crashes that come with testing new algorithms? The Go2 X survives repeated falls and outdoor conditions that destroy hobby-grade robots. The Python and C++ SDK, combined with active GitHub repos and growing community support, means you're never stuck debugging alone. Yes, battery life under heavy AI loads runs about 90 minutes, so plan for swappable packs if you're running compute-intensive workloads. But here's the reality. You're getting research-grade quadruped mobility, full programmability, and a complete sensor suite for roughly 1/10 the cost of competing platforms. Are you still limiting your research based on hardware you can't afford, or are you ready to build what you've been imagining? Here's the real transformation. You go from watching simulations to deploying autonomous behaviors in the real world, from theoretical papers to field-validated research, from waiting on budgets to prototyping today. Thousands of developers, university labs, and robotics startups already trust the Unitree Go2 X as their embodied AI platform for exactly this reason. It delivers the performance without the barriers. If you're ready to move your AI from screen to physical reality, the affiliate link is in the description and pinned comment below. Full disclosure, I earn a commission on purchases at no extra cost to you. Explore the Go2 X and finally build the robots you've been planning.
For demo videos and current pricing, check the link in the description.